Hey there. So, just the other day, I made that video about the difference of two squares, how to factor difference of two squares, and I was talking about how it shows up in standardized tests all the time, and it's really important. Well, today, I was tutoring a student for the GRE, and two problems came up on our studies that had to do with difference of two squares. So, I figured I would show you those problems so that you can see what they can look like on a test like the GRE when they pop up and what you might look out for, and maybe decide to pay attention to learning to do difference of two squares because it really does come up all the time. So, these two examples that I'm going to show you, I mean, you might consider them maybe kind of tricky GRE problems unless you were really comfortable with difference of two squares. So, and now that I've told you in advance that these are going to be difference of two squares problem, you might just see it really quickly. But if you weren't hyper aware that difference of two squares existed, then you might have thought that this problem was kind of a hard problem. So check it out. The first one says, if x minus y is the square root of 12, and x plus y is the square root of 3, what is the value of x squared minus y squared? And gives you some options. So if you're in a mind to be paying attention to the difference of two squares, then you would see this thing here, and you say, oh, look at that. That thing is the difference of two squares. And so you could go about factoring it, and you could say, oh, that's really fast. Since it's the difference of two squares, it's just x plus y times x minus y. And then you go, oh, wait, look at that. They gave me x plus y and x minus y. It's just going to be x plus y is root 3, x minus y is root 12, root 3 times root 12 is root 36, which equals 6. Answer B. Okay, so if you know difference of two squares, this problem all of a sudden is actually very, very easy. And if you didn't spot that it was a difference of two squares problem, you might have scratched your head for quite a while looking at this GRE problem. Okay, let's look at the next example. So next one says, and it maybe doesn't all quite fit from there at once, that's okay. If x times y does not equal 0 and x does not equal negative y, then there should be an equal sign here, then x to the 36th minus y to the 36th over the quantity x to the 18th plus y to the 18th times the quantity y to the 9th plus, oh, dang it, that should be an x to the 9th plus y to the 9th equals what? What does that equal? So again, if you might originally see this problem and go, wow, that looks like a mess of junk. I don't know. But you might notice this up here. Whoop, this up here. You might look at that and go, ooh, but that thing upstairs, that is a difference of two perfect squares. Because you know that even power is easy to take the square root of. It's just, half of those 36 factors. So it's x to the 18th, okay? And so because you can see that, you go, oh, this is easy, it's difference of two squares. And so you factor the numerator to x to the 18th plus y to the 18th, and x to the 18th minus y to the 18th, using difference of two squares. And then you start to notice some nice things happening that you notice that that whole thing, that whole factor down in the bottom, x to the 18th plus y to the 18th, and this one on top cancel out, okay? And then you're back to like, oh shoot, but I don't know how to go any further, and this doesn't look like any of the answers there on the left. But once again, you look at this structure here, and you go, hey, that's once again the difference of two squares, because the square root of x to the 18th is x to the 9, and the square root of y to the 18th is equal to y to the 9. And so you decide, okay, well, I'll just factor that out, see where that gets me. You'll get x to the 9 plus y to the 9, and x to the 9 minus y to the 9, all still divided by that, x to the 9 plus y to the 9. And again, you go, oh, sweet, some stuff canceled, those two go away. And so you get that this entire thing is equal to option C here, x to the 9 minus y to the 9. So those are a couple of examples showed up on GRE study, and I almost guarantee that on a test like the GRE or the SAT or the ACT or ACT or the ASVAB or pretty much any standardized test, you're going to run into at least a couple difference of two squares factoring problems. And if you see them, they're really fast. And if you don't see them, then they're really slow and weird. So anyway, get good at difference of two squares. See ya.